Hey everyone, welcome to the first session of our brand new feature in Reskill, Leader Speak, where you can learn from the top AWS leaders and experts and upskill yourselves. What's more, once you attend the session and submit the feedback at the end of the session, you'll get 100 points and a certificate of participation. So, without any further delay, I'll introduce our expert, AWS expert of today's session, which is Sushit Ripukala, an AWS serverless hero who is passionate about building serverless applications and has shared his prolific experience at various events across the globe. So, without any further delay, I'll bring him to the stage. Hey, Sushit.
Hey, hi Karthik. How are you doing?
Yeah, I'm fine. First of all, thank you for joining this session and helping us upskill.
My pleasure.
So, Sushit, could you please give a brief introduction about this session and about yourself?
Sure. Can you please add my presentation as well to the screen?
Sure.
Okay. So, first of all, a very warm welcome to everybody who's joining us today on a Friday evening uh, for this session on Reskill, the first session of Leader Speak from Reskill. So, today's session is about serverless, your gateway to the cloud. I'll be talking about the very basics of serverless and how or why serverless is probably one of the things that you should be looking at if you're getting started yourself into the cloud. That's why I've called it as your gateway to the cloud, your entry into the cloud, essentially. So a little bit about myself. I'm Srushit Repakla. I'm an AWS serverless hero. I'm the head of engineering at Confirm. I'm also an serverless consultant, and I do a lot of community activity, organize a bunch of meetups, and yeah, I also am an organizer at a user group, AWS user group. So a server that is so 2014, right? I mean, we've been having hearing about using servers for quite some time now, and it's a law of nature to enhance, upgrade ourselves to new things, isn't it? And servers have been around for quite some time now, and it's using a server is so 2014. That's almost a decade back. So what is serverless? Serverless computing, or serverless for short, is an execution model where the cloud provider runs a piece of code on demand, and we will only be charged for the amount of resources that we use of the cloud provider. So essentially, to put it in simple one-liner, uh, serverless is basically a computing mechanism where the resources are provided on demand by the cloud provider for us, wherein we just provide our code. The cloud provider executes that piece of code on demand as and when there are requests coming in, and we are charged only for that. As simple as that, right? Now, how did we get here? What is from where did we get into serverless, right? So, in the initial stages, we had the physical machines, wherein we used to buy servers and have them in house, have a proper cooling mechanism, electricity, a lot of hassle, right? A lot of management was there. And then came in virtualization, then came in cloud, then we had containers, uh, and then now we have serverless, right? So at every single point in time, there has been an abstraction from an engineer or a developer. So in the world of physical servers, the engineer or the developer had to manage, maintain, and take care of hardware, OS, runtime, and the code, of course. Right? In virtual machines, what happened? The hardware was taken away from us. Now we just had to rent something on the cloud. In the world of containers, the OS also kind of virtualized, wherein kind of abstracted from us. not virtualized, sorry, kind of abstracted from us. And then in the world of serverless, all we have to care about is the code, right? As developers, as engineers, what is the most important thing that we have to be thinking and worrying about? It is solving real world problems, making sure our customers are able to use the applications and solving real world problems, right? As engineers and developers, we shouldn't really be worrying about the underlying infrastructure, underlying things. We should be focusing on solving real world problems, not about the things that is not really going to help my application or help me in serving my customers. Of course, infrastructure is a very, very, very important and integral part of your application, but still, as developers and engineers, our major or main focus has to be writing code, right? And that is where serverless, kind of comes into the picture and does a lot of things for us. Now, if we dig deeper a little bit and understand what exactly this is, so we have four, as I mentioned in the previous slide, we have four pieces: physical servers, virtual machines, containers, and serverless. Let's take a little bit of a deeper look and understand at every individual piece what exactly happens. In physical machines, like quite a lot of time back, what used to happen is the engineers had to do a lot of planning. Basically, we had to buy servers and have it installed at our place and then deploy the code on top of it and then get it working, right? Which meant that it required a lot of planning, and not only planning, a lot of guesswork of planning, because my as an individual, I don't know how my application is going to behave, right? How my app behave in the sense from a business perspective, right? How is the market going to consume my application? How are my customers going to perceive my application? Am I going to get a lot of requests or a lot of scale because whatever I've built is amazing, or I have not built such a great product, so there's not going to be a lot of scale. So essentially, a lot of planning had to go before itself for us to have proper infrastructure in place. And this lives for years on premises because essentially we are spending a lot of money and buying the infrastructure and having them in house, which is on prem, right? And with this, it involves a lot of heavy investments because we are paying money and getting the infrastructure into the place, right? Low innovation factor and deploy in months. So I will be touching about these 2 points more as we go higher in the abstractions. The second after physical machines came in the virtual machines, where, as we saw in the previous slide, one layer was abstracted away from us, which is the physical layer. Now, instead of having to buy servers, manage and maintain them, me as an individual, I would rather give that responsibility to the cloud provider, wherein I just say, I go to AWS and say, within a few clicks, I can get a VM or an EC2 machine provided for me with a dedicated, with whatever specifications we want. What is the RAM? What is the size of the machine? How much power you want? And stuff like that. So with virtual machines, what happened is we had hardware independence, faster provisioning speed. So imagine, our application is getting a lot of requests, a lot of traction. Then instead of in the world of physical machines, I had to just go and buy physical machines and add it to my fleet of machines, right? But instead, in the virtual world, I just have to go to AWS and spin up another EC2 instance, and within a few minutes, I will have my infrastructure available for me. Now, then we have the trade for capex or for opex. So basically, instead of capital expenditure, which we had in the physical machines, wherein we had to buy things beforehand, we now do operational expenses where we just have to understand how much or when do I need that extra virtual machine in the place, right? So what we would do is we just had to plan for how much. As and when the requests are coming in, we just had to plan the uh, uh, the machines that I want and get the machines available on the cloud within a few minutes. So it is more of an operational expenses from a planning perspective that I need rather than the capital expenditure. So that is about the trade for capex for opex. More scale. Now that I have kind of access to unlimited resources, not exactly unlimited, but if you think about it, the entire cloud is available for you. So I can have now, as and when my requests are coming in, I have the capability for my application where I can bring in more servers, add it, and get my application up and running when there is scale, right? Faster speed and agility, like I mentioned, reduced maintenance because, of course, we don't have to take care of the physical machines anymore. Now, containerization. Containerization is basically these are the advantages, right? Wherein we have platform independence because in a container itself, I am packaging everything that my application needs. So I'm not really under depending on the underlying infrastructure. Then we have consistent runtime environment because again, I'm packaging the entire the entire application together. So I am specifying what I want. So there's a consistency of the environment available, higher resource utilization. So I'm not wasting the resources underlying, easier and faster deployments, isolation and sandboxing, and startup speed. So generally we can deploy containers in a magnitude of few seconds, right? In the world of serverless, what happens is we have continuous scaling wherein we don't have to worry about the underlying infrastructure, rather, the cloud provider takes care of that. So, as and when there are requests coming in, the cloud provider AWS takes care of this and makes sure that our Lambda functions are scaling up and able to serve as many requests that is coming in. So we have built-in fault tolerance, pay for value. Again, a very important or one of the uh, biggest advantages of serverless is pay for value, which is essentially meaning that I only pay for how much I consume or how much my application consumes, right? So instead of paying for idle time where there are no requests coming in and I don't have to worry about paying the infrastructure cost for my application, I just pay for how much I consume. Then we have zero maintenance because of course we are not maintaining the underlying infrastructure, right? So we don't have to worry about what is uh, uh, underneath. Now this is on a granular level. What is the differences, pros and cons at every abstraction level that we have in the system today. Now, for people who don't know serverless or are pretty new to serverless, one very simple analogy for you guys to for you folks to understand, I would give is we have, let's say there are three things: physical machines, virtual machines, and then serverless, right? Um, so it is one very simple analogy is cars, right? So if you have to buy your own car, you have to shell out a lot of money. You have to pay it in lakhs of rupees and then get the car to yourself. The advantage is the car is yours and yours only. But then you have to pay a lot of money upfront, and irrespective of whether you are using it or not, you have already paid for it. And you have to maintain the car as well. So whatever the maintenance cost, everything you have to bear for that. Now, in the world of cloud or virtual machines, it's more like a Zoom car, wherein you don't have to buy the car for yourself, but rather rent it out as and when you require it, right? So let's say I have planned a trip for from place A to place B. So then essentially I'll just rent out a Zoom car for a couple of days and pay only for those couple of days. Now, again, what is the problem there? The problem is that uh, you know uh, I have to do a little bit of a planning, which means that I have to understand how many cars do I want, how many people am I traveling with, one or two. So there's a little bit of a planning. And the second one is, of course, you don't have to take care of the maintenance of the car because Zoom car takes care of that. But still, you have to drive it, which means that you there's no driver for you, right? So you're kind of maintaining it for a small period of time. And then the cost factor. So irrespective of whether you're driving or whether you've parked your car outside your home, you have to pay money to Zoom car, right? So that is what virtual machines is. Irrespective of whether you're uh, using it or not, you have to pay for to the cloud provider. Now, with the world of serverless, it is synonymous or analogous to what Uber or an Ola is. So essentially, I want to go from one place to another. Do I really have to plan so much before? No, I just open the app and I just search the place where I want to go to, and then book an Uber. So there's not essentially a lot of not a lot of planning. Essentially, there's no planning at all. I just want to go. I'm going there, right? And the service is available for me. And apart from that, I just have to pay for how much I consume, right? So I don't have to pay for the car, pay for the driver, pay for the fuel, pay for the EMI, insurance. I mean, I don't have to take care of any of those things. I'm just paying for my ride from place A to place B, as simple as that, right? So I will be charged only for that. And if, let's say, for example, I'm traveling with 10 people, I just have to book probably 3 cars. If I'm traveling for 20 people, I will book 5 cars, right? So as and when there are a lot of people coming in, I can book as many cabs I want, right? Now this is what happens in serverless as well. So your objective is running a piece of code. Cloud provider AWS takes care of running it for how many ever requests come in. Of course, there are some limitations, throttling limits and other things, but I hope you understand the bigger picture, saying that I, as a engineer or a developer, don't have to worry about it, and I'm pushing that responsibility to the cloud provider, and they will take care of running my piece of code and executing it for all the requests that is coming in. So this is a bit about what is serverless. And now why did I term serverless as your gateway to the cloud? Now, if you're getting started with serverless, or in fact, not serverless, sorry, getting started with backend, getting started with the cloud, there are a lot of things that you have to learn and understand, especially if you go to the EC2 world, or in fact containers. There's a lot of technicality that is there for you to learn and understand, right? But with serverless, since the only thing that matters is your code, I don't have to worry about anything underlying or it. I just have to worry about my code, get started, and up and running as quickly as possible. One of the pros of serverless is the faster go to market, wherein I have an idea, I want to implement it, just push it out to the production, give it out to the customers, and see how people react to it. Now, what are the other advantages? I think a few of the things that we have already discussed is configuration less scaling. We will be touching upon this a little more as we proceed further. No servers to manage, which means lesser headache for us. Bring your own code. As such, we don't really have to make a lot of changes to our existing code if you have to make it a Lambda function. But there are a few things that we will have to be considerate about. One thing is uh, in the world of serverless, one thing is it's all event driven, and the second one is it is stateless. So we cannot maintain a state between two invocations, and therefore that is something that we have to keep in mind and code accordingly. And the next one is built-in fault tolerance. This is something that we have already discussed about, and pay as you go, the costing factor. Now, one of a couple of things that is very lucrative or tempting for people to try out serverless is not only the headaches that we are losing, but also the costing factor and scaling. So, cost, it's cheaper comparatively because we are not paying for when we are not consuming, and scale because it can automatically scale without any problems, or in fact without any human intervention in the place. No, I've been talking about serverless, and a lot of theory, right? Now, what exactly it is? How does it work? What is it working with serverless, right? So we have a few event sources, and we have our Lambda functions, and we have a few triggers. That is other services, right? Let's take a very simple example of you have an application that takes care of converting images from PNG to JPG or any format, from one format to another, right? So what we will do is when a user comes to your application or your website, all they will do is upload an image to one S3 bucket. And we can configure a lambda function to be triggered when an object is inserted to an S3 bucket. So the lambda function will come alive, and then it'll automatically, I mean, not automatically, I mean, it'll have your business logic, whichever you want, lossless compression, whatnot. You can do anything that is your business logic that converts the image from one format to another, and then probably upload it to another S3 bucket. So the event source here is an S3 bucket. Here is the business logic, wherein the image conversion happens from one to another. And then we have the other trigger sources, like I'm uploading it to another S3 bucket, or probably sending out an email and stuff like that. So this is one of the most common examples that we have. And as I mentioned in the previous slide, everything in the world of serverless is event driven, meaning for my application I mean, for my lambda functions to run, there should be some kind of an event that should trigger it. Okay, so this is a little bit about serverless. There are numerous triggers that is available on AWS that can trigger your lambda functions and execute your piece of code, and then do whatever it has to do. For example, update a database, or if it's an API, we can probably return a response back to the UI, to the client, and stuff like that. Now, so what exactly happens with a lambda function, right? So if you carefully observe this diagram, there are two pieces to it. One is on the left hand side, and the other one is on the right hand side. So uh, 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 on the left hand side is what is called as a cold start. So there are two things that I would like to let you guys know. So which is in the world of serverless, there are two things. One is cold start, and the other one is a warm start, right? So what is a cold start and what is a warm start? That is what we will be discussing here in this particular slide. So uh, the left hand side is what happens uh, inside a cold start. So essentially, we will whenever a request comes in, we have our AWS provisions here, and infrastructure for you for the application, downloads the code which we had uploaded into AWS, and then creates the execution environment for the application to run, right? So that the amount of time it takes for AWS to provision the infrastructure and environment for us is what is called as a cold start, right? And then I mean, the amount of time, right? So what is a warm start? So basically, a warm start, which is what we see on the right hand side here, wherein we just have to this is where our application code executes, right? The Python or JavaScript Node.js code that we have uploaded to AWS, uh, that piece of time when it runs is this is the warm start uh, piece. Now, so what is the difference, or why is this very important to understand? Is essentially whenever a new request comes in, AWS has to provision the infrastructure for us and deploy the code and run it for us, right? So it will take a bit of a time, right? A few milliseconds for AWS to provision that deployment. Now, why is it this bootstrap the runtime, which is the partial cold start, uh, is again very important. And as you can observe here, the left hand side is AWS optimization, and the right hand side is your optimization, right? So this side of the diagram, we don't have any control and any optimizations of reducing that amount of time that AWS needs to create that environment, and everything is AWS's hand. So they keep enhancing it and reducing the amount of time it takes. And the right hand side is our piece of code, and it is our responsibility and how we optimize our code to reduce the amount of time it takes for the lambda function to complete the execution, right? Now, why is it important to understand this? There are two things. The first one is the deployment size. Your code size is kind of relational to the amount of time your API takes to execute, or lambda function takes to execute, right? The more heavier dependencies and heavier modules you have in your code, the longer it will take for AWS to download that piece of code and set up the environment, bootstrap the runtime, for us, right? So essentially, it is very, very important in the world of serverless for us to pick up or consume as many less modules as possible. I mean, of course, it's not possible for us to eliminate all of them, but in the world of serverless, this becomes a critical piece so that whenever you're building your application, try and see if there are other modules that are lighter in weight available that is solving your purpose, and if so, choose that so that your cold starts will be reduced comparatively, because the amount of time it will take for AWS to download that piece of code and get it available will be reduced, and eventually improving the performance of our Lambda functions, right? So this is one important thing to understand and remember in the world of serverless when we are building applications, right? Now, the second important thing that we have to understand is I had mentioned that serverless functions have to be stateless, right? Which means that one Lambda function cannot remember what happened to the I mean, the invocation of one Lambda function cannot remember what was the details of the previous invocation, right? But having said that, there are a few things that can still on a level a state can be maintained. Now, for this to understand, let me give you a brief understanding of what happens behind the scenes. So I told you in the beginning that serverless is nothing but infrastructure on demand, right? So as and when requests coming in, the resources are provided by AWS, and the code is executed. Now, theoretically, once the code is executed, AWS has to kill the infrastructure, because, I mean, it has served the purpose, right? There's no point of keeping that infrastructure still, because, of course, we are not going to be charged, but if it's not killed, AWS will be charged for the same, right? Now, but is that what happens always? Now, the answer is no. What happens is on what happens on AWS is once a request comes in, the infrastructure is provided, and after the execution of that request, AWS still keeps the environment alive for a small amount of time. So that if there's another request that is coming in subsequently, AWS doesn't have to create an environment again, but rather reuse what is already present, right? So now this is what is called as a warm start. So basically, instead of the life cycle being completely from all the way from left to right, the life cycle is cut down to only what is on the right hand side, right? So the advantage is, of course, for the end users, the consumers of Lambda functions, wherein the warm starts will be lesser, time consuming than compared to sorry, cold starts will be longer compared to comparatively to the warm starts, right? So this is one important thing to consider, and the statelessness, right? So one thing again to remember, which not a lot of people who are getting started essentially will know, is anything that is executed at the global level, right? Any global variables that you have in your application logic or anything, all those things are kind of maintained for the entire period of one cycle, which means that until the environment is killed, right? The global variables are maintained and can be accessed across your invocations, subsequent invocations. Now, again, one important thing to remember is, as I mentioned, once the environment is gone, these global variables are also gone, right? So until and unless AWS is maintaining that environment, and if we are getting requests coming in, then we can kind of reuse those global variables. Now, one of the major advantages of this one that we can consume or leverage is basically what people generally do is connections to the database, right? So instead of initializing connection at every single Lambda function invocation in the handler function, rather, if we initialize them at the global level, we can reuse the connections to the DB across our subsequent invocations, so that we can reduce the amount of time and kind of reduce the number of requests as well. Again, one another use case of leveraging this is secrets, right? So a lot of times we will have to retrieve secrets from another external party, like you probably need to get your database credentials in secrets manager, or app config, some places like that. So instead of fetching that in every single invocation, rather we if we put it at the global level, then we can kind of reuse them, and reduce the number of requests we are making to that external service, therefore reducing the amount of cost as well. So this is another important piece to remember, so that we can enhance the not only from a performance perspective, because it will be faster, but also from a costing perspective. Now, another, as I've been talking about, one of the major advantages of a serverless is scalability. Now, in the world of servers, scalability is something that is, kind of human intervention is in some ways required, and a lot of planning is also required for it to happen. With the world of serverless, now this is one of the biggest advantages that we have, right? So so this is a real world example that I have put up here. So here what happens is, as you can see here, this is some metrics from one of our applications, wherein we had built a quiz application for one of the AWS community days that happened last year. And as you can think about it, right? So a quiz application is short lived. Probably the application is consumed for 10-15 minutes, which is a very short period of time, but again it can be consumed across the day for multiple times, right? Now, these are metrics from that particular application, where we had close to some 25 to 30,000 users using the application concurrently. And therefore, as you can see, in the morning at around 10 a.m., there's a huge spike in the number of requests that the application received. And we had built this application completely serverless. So it was lambda functions, obviously, and dynamodb was the database that we consumed. Now, since the application was completely serverless, we as engineers did not have to do anything. We just had to sit back and just see the application scale on its own. We didn't have to worry about provisioning more infrastructure, what will happen, and a lot of things. Until and unless, I know, of course, as I mentioned in the earlier slides, right, there will be some throttling limits and some account level limits. If you have taken care of those, then you don't really have to worry about the application scaling, and it automatically scales. So what happened here is, in the morning, as you can see, the number of requests was almost very minimal. And then slowly towards the start of the event, the quiz was conducted at the start of the event at around 10 a.m. Is a sudden spike, right? It went all the way from close to zero, and then probably 5K or 2 to 3,000 to suddenly 25,000 approximately, right? So that's a huge jump, right? Now, so in the traditional world of applications, now this is sudden jump, right? Now we have to make sure the application handles the scale, sudden jumps and everything. But in the world of serverless, nothing. We just didn't have to do anything. There was a sudden jump. The lambda function scaled automatically, and DynamoDB can scale to trillion requests. I mean, this is just a few thousand requests, right? So it is nothing to DynamoDB. So it just scaled automatically without without any human intervention. And as you can see here, once the quiz was over, as I said, it's a very short-lived activity. The number of requests came down because the quiz was over. So from 0 to 25K in the span of 10 to 15 minutes, and then again in the span of 10 to 15 minutes, it came back all the way to zero, right? So scaling is not only about scaling up, but it's also about scaling down, right? It's important because you just cannot keep your servers up and running just because you had scale. You just cannot keep it up and running over there, right? You have to bring it down, otherwise you'll have to pay extra money to AWS, right? So with serverless, it is not only about pay as you go, which is how you pay for how much you consume, and the costing is why is it cheap? It's because You're not paying for when you're not consuming it, right? Every penny saved is every penny earned, right? So whenever there's no request, I'm essentially kind of saving it, right? I'm not spending it, I'm kind of saving it. So we had a sudden burst, so it went up and then it came down. And then again at 11 o'clock, there was again one more quiz, so it went up. And then there was another quiz here, there was another quiz here conducted. And then towards the end of the day, there was a quiz. And after that, there were no quizzes at all. So as you can observe here, there was a sudden huge spike and then normal spikes here and there. And then towards the end of the day, nothing at all, right? So what is it? What does this tell us? In the world of serverless, everything is taken care. The cloud provider is taking care of it. You don't have to worry about it. Just sit back and enjoy the application scaling for you. And also, as you can see here, we are not paying anything here because we're not consuming or any Lambda functions is not running. So essentially, we are not paying anything as well. So that is the advantage that I was talking about. Now, I've been talking about Lambda functions all along the way, right? Serverless is not only Lambda functions. This is again a big perception that a lot of people who are getting started have, right? So serverless is not only Lambda functions, right? So serverless is something like this, right? You have so many services available on AWS. I will be showing what are those. Now, all you will have to do is bring them together and make a beautiful picture out of it. As a developer, that is your responsibility. So, in the world of serverless, we don't build everything from scratch. We don't reinvent the wheel. We rather consume what is already available, go with cloud native services, and use it. One simple example is instead of building and managing and maintaining my own authentication and authorization service, I would rather consume something that is already available, like Cognito, right? It so very natively integrates into my API gateway, does a lot of things automatically. I don't have to worry about it, and I just consume it what's already there, so I don't have to worry about the security best practices and everything because you're kind of consuming a service, a cloud service. The best practices, some of the best practices are already in place, and you don't have to worry about maintaining and managing the infrastructure for those services, right? That's a huge plus because now I can focus on what is very important and very specific to my application that can solve the needs for my customers. Similar to SQS, I mean queuing system. Instead of having my own queuing mechanism, I can rather rabbit and queue and whatnot. I can simply consume SQS. I can use S3 buckets. I mean, S3 buckets is something that everybody uses, but all these things, instead of writing our own or consuming, we can rather use what is already available. As I mentioned, serverless doesn't mean Lambda functions alone. It is one of the compute offerings. Now, under compute, we also have AWS Fargate, which is the containers, serverless flavor for containers, and then application integration. We have so many services that we can use. As I have already talked about SQS, we have Event Bridge. So instead of Event Bridge is again a serverless service for event. You can have event buses, and the advantage of Event Bridge is it gives a lot of features like replay, storage of events, and the integration to various other AWS services available out of the box, direct native integrations, right? Then we have step functions. So what is a step function? A step function is basically a workflow kind of a thing wherein you can orchestrate your Lambda function, saying that, I first want to execute Lambda 1, then Lambda 2, then Lambda 3, and then based on the result of Lambda 3, I want to execute Lambda 4. So a lot of these orchestration can be done using step functions. Then we have SQS, which is a queuing service, SNS notification service, API gateway to create API endpoints, and then AppSync also is available, which is basically a GraphQL managed GraphQL service, so we can create GraphQL APIs on Lambda function and integrate it with the database or Lambda function and everything. Now, from a data store perspective, we have already talked about S3. Then we have DynamoDB, which is NoSQL database. We have Amazon Aurora Serverless. So DynamoDB is NoSQL. If you want a relational database, then we can go with Aurora Serverless. And then we also have something called as RDS proxy. So if you have a normal RDS instance and your but you want to, your lambda functions can scale, but your RDS instance cannot, right? I mean, there are some limitations because you have size limitations, the number of connections and stuff like that. So we can use RDS proxy. So the connection management and everything will be taken care by RDS proxy. So there you'll have lambda function, then RDS proxy in the middle, and then you have the database. So what are the various use cases for serverless, right? So we have web applications. We can build chatbots. Again, chatbots is a very, very, a great example for serverless because it's all event driven, right? So as and when there's a message coming in, I have to deliver it to the recipient, right? And then data processing, autonomous IT. Then we have backend as a service. So you can have APIs that is built that can serve your web applications or mobile applications. So the use cases are numerous, but one thing that I would like to mention here is the fact that serverless is probably not the right fit for every single use case out there, right? So it may not fulfill your every single need. One simple example is, a lambda function has a timeout of 15 minutes, right? It cannot execute or run for more than 15 minutes, right? Now, if you have situations or scenarios like that, then you will probably have to look out for different options. You could consider AWS Glue or some other options available. So a very important thing to keep in mind is serverless. Of course, it brings in a lot of advantages, has a lot of pros to it. It's important as a developer, as an architect, to understand whether serverless is the right fit for my particular use case or not. So that is one important thing to keep in mind. Now, I would like to conclude this session with this comic strip. So, what comes after serverless? Codeless, deployless, CPU-less. As we had seen, we have kind of reached to an abstraction level where all we have to worry about is code. Right now, what next? I mean, we don't know what it is, but of course, we have seen what GitHub Copilot and every of those things can do. It can write the code on its own, just provide a problem statement. So, yeah, I mean, codeless. I mean, not exactly there, but looks like we are heading towards that. But whatever it is, as we will still have problems, we will still have things to worry about and care. So whatever it is, it cannot be bugless, right? So with that, I would like to conclude my session and one simple reminder: don't deploy your applications today. It's a Friday evening, so don't deploy your applications. So that's it for today. Thank you very much. This is Rishit Repakla. I'm the head of engineering at Confirm, and you can follow me on Twitter. You can get connected. If you have anything about serverless, I'll be more than happy to discuss, talk, and just chat with all you guys over there who are enthusiastic to talk about. So that is about it, and thank you so much for coming and joining this session.
Hey, Srishit, am I audible?
Yes, yes, Karthik. Now you are.
Yeah, sorry, a slight. So it was an amazing session, Srishit. We have a question for you from the comments.
Yes, please.
Is serverless mainly replacing the API like deployments?
Um, I mean, I couldn't really understand a lot about the question. So, if I understood, I mean, is it replacing API deployments? I mean, the question is not. I could not really understand, but if I have, from what I understood, if I have to answer, it's not a replacement for API deployments. You can do a lot of other things with serverless. A lot of background processes, cron jobs, a lot of other things is also possible with serverless. So it's not only APIs, a lot of other things can be done. And it's again not a replacement, but it's like another flavor or another option that is available out there.
I hope that answers your question, Santosh. If you guys have questions for Srishit and regarding this session, you can reach out to him. His social media channels have been mentioned on the screen and also available in the description of this YouTube video. And so regarding the reskill leader speak feature, so people who have registered and attended this session, for them a feedback option will be available on reskill, and you can give the feedback, and a certificate of participation will be sent to your email addresses. And thank you all for joining this Friday evening. It was an awesome session with Srushit.
Thank you.
Thank you, Srushit.
I think we have one more question, right? So,
Is it there? Okay.
yeah, yeah.
Okay. All right.
Right. So yeah, is serverless available only in AWS? No. The answer is no. So serverless is available across cloud providers now. Uh, Almost, I mean, everybody has. So like for example, on Azure we have Azure Functions. GCP also we have functions, and there are a lot of open source flavors also available like OpenFast. We have something called as Kubeless. So every cloud provider has an option, and there is open source also available. Yeah.
Thank you, Srushit.
Thank
I hope this answers your question, Manraj. And yeah, if you guys have any more question, as I said, you can reach out to Srushit anytime. The link is in the description. I'm mentioning again. And thank you all for joining. Have a wonderful weekend ahead.
Thank you. Thank you so much, everybody. Have a wonderful weekend. Bye bye.